Hi everyone. So in this video we are going to study some miscellaneous topic which I forgot to explain in the previous videos. So I forgot to explain about multi-stage amplifiers. Although you already know everything about it, we have also seen the examples as well, but let's just treat it as a topic. So what is a multi-stage amplifier? You connect a lot of amplifiers in series. Like here you are having one of the amplifier. This is your amplifier 1. You give it some input, then you get some output. This is the input and you get some output, that is V01. Now this output would become the input of the second amplifier. This output would become the input of the second amplifier. Now you get some output. Now this output would become the input of the third amplifier. Then you get some output and then this series will go on. So there are multiple stages connected in series, or you can call it connected in cascade. So these multiple stages are connected in cascade and then you get the final output. So here there will be some gain, here also there will be some gain, here also there will be some gain. So this gain will be multiplied. These gains will be multiplied. How it is multiplied, we will see it. So let's take an example, then we will see it. This is the simple definition written here. A series of amplifier in which each amplifier connects its output to the input of the next amplifier in the chain. So output is connected towards the input of the next amplifier in the chain. That's it. Right. So let's take an example. You have to find the V0 by Vs value. V0 by Vs. So what do you see here? This is your one stage. This is one of the amplifier. There are two modes connected. So this is your stage 1 and this is your stage 2. So there are two stages. So this is an example of cascade amplifier only. This is stage 2. Right. So what will be the gain here? Let's just assume this potential is Vx. So what is my Vx by Vs? First tell me what is my Vx by Vs. That is minus Gm into Rd1, then R1 parallel R2 divided by R1 parallel R2 plus Rs. Is it fine? This potential, whatever the potential we are having here, that would be R1 parallel R2 divided by R1 parallel R2 plus Rs. This potential would be this one, and that potential will be amplified with this factor. That would be minus Gm Rd1 upon 1 plus Gm Rs. Minus Gm Rd1 upon 1 plus Gm Rs. Right, and Gm1 we can call it. We can call this transistor as M1 and this transistor as M2. What is this? This is a common source amplifier with degeneration. Do you remember the gain of common source amplifier with degeneration? That is GMRD upon 1 plus GMRS. GMRD1 upon 1 plus GMRS. This is the gain of common source amplifier with the degeneration. Now, this will not be the complete gain. Why so? Because here there will be some reduction in the gain. Voltage division would be there. That voltage division would be R1 parallel R2 upon R1 parallel R2 plus Rs. And this is the gain, that is GMRD upon 1 plus GMRS, and negative sign is certainly there since because this is common source amplifier. Now this amplifier will get some gain from here. Now this Vx will be amplified from here. So what, how V0 by Vx you could write? What is V0 by Vx? That is minus Gm2 into Rd2. Say yes or no? V0 by Vx is minus Gm2 into Rd2. So from here it will be amplified. Vx will be amplified by Gm2 factor. So this is equation 1 and this is equation 2. So gain of first stage is this. This is the gain of first stage and this is the gain of second stage. Now you need to find the total gain, so you will just multiply both of the gains. If I multiply equation with 1 with 2, multiply equation 1 with equation 2. So what I will get? Vx by, that would be Vx by Vs into V0 by Vs. So what I will be getting? Sorry, V0 by Vx. Vx by Vs into V0 by Vx. So Vx getting cancelled, so it would be V0 by Vs. V0 by Vs, and both of them will be multiplied. So Gm2 Rd2 into Gm1 Rd1 upon 1 plus Gm1 Rs into R1 parallel R2 upon R1 parallel R2 plus Rs. That's it. This is the final gain. This is your final gain, right? So that's it. This is cascade amplifier only. This is multi-stage amplifier. There are two or more stages connected. So first we wrote down the gain of this stage, which we have already seen. These kind of example we have already seen. Minus GMRD upon 1 plus GMRS, and then voltage division here R1 parallel R2 upon R1 parallel R2 plus RS. And from here to here the gain is minus GM2 RD2. So the total gain would be GM2 RD2, GM1 RD1, 1 plus GM1 RS, R1 parallel R2 upon R1 parallel R2 plus RS. So this is the final gain. That's it. Write down the gain for this one. Do it on your own, then only watch the solution. So let's just call this potential as Vx. So what will be your Vx by Vs? Will it be minus GMRD? Let's call both of the transistors are equal only this time. So minus GMRD upon 1 plus GMRS. Is that your answer? Vx by Vs. What is your Vx by Vs? Is that your answer? Wrong. Why is it wrong? From Vx to ground you see RD. From Vx to ground you see 1 by Gm as well. Let's just say this is grounded and this is also grounded because we are doing the AC analysis. So you cannot write that sir from Vx to Vs I see minus GMRD upon 1 plus GMRS. But why did we write in this stage? In this stage I could write it because gate will drive 0 ampere current. So there is no loading. There is no loading. So from Vx to ground you only see RD. From Vx to ground you see RD. From Vx to ground here you see open circuit. So the impedance was RD only. But here in this example from Vx to ground you see RD, but and from Vx to ground you see 1 by Gm as well. So this is 1 by Gm as well. So what will be Vx by Vs? Vx by Vs would be minus Gm. In place of load resistance, what would come? RD parallel 1 by Gm. Let's call this one as M1 only and M2 only. So minus GM1 RD parallel 1 by GM2 divided by 1 plus GM1 RS. So this is your Vx by Vs. Now what about Vx by V0? What about Vx by V0? Now your target is to find Vx by V0. So since this potential is Vx, then what is the current flowing here? That would be Gm to Vx, and V0 would be, look, this is Vx potential and this is grounded. So what is the current in the upward direction? Gm to Vx. So V0 would be Gm to Vx into RD because this will be grounded as well. So V0 would be Gm to Vx into RD. So V0 would be Gm to Vx into RD. So your V0 by Vx is Gm to RD. Right? This is your equation 2 and this was your equation 1. So what will be your V0 by Vs? V0 by Vs would be Gm2 RD into Gm1 RD parallel 1 by Gm2 upon 1 plus Gm1 RS plus Gm1 RS, and then there is this negative sign. You cannot forget this negative sign. So this will be the total gain. This is the total gain. Well and good. Everything is crystal clear to you. What you need to do? Okay, yeah, I thought the video is paused. Yeah, so what you need to do, you just need to write the gain of the first stage, then you need to write the gain of the second stage. In the problem solving, what I will do, I will just write down what will be my Vx. My Vx would be how I will solve the problem quickly. So what I will do, I will first write down the value of Vx. So Vx would be GMRD upon 1 plus GMRS, sorry, RD parallel 1 by GM minus sign into Vs. Now what I will do, I will replace my Vx. How I will replace my Vx? My Vx would be equals to V0 by Gm to RD, because Vx would be V0 by Gm to RD. V0 by Gm to RD. This would be my Vx, right? Gm to RD. This would be my Vx. Now this Gm to RD will go here. So then I can write down my final gain. So quickly you can do in this manner, or you can write down the gain in this manner as well. That from here to here gain, then from here to here, right? minus G into RD. So this is the final answer. That's it. So in this manner only you need to find the gain if they ask in the examination. So now we are going to study about pass transistor logic. So in pass transistor logic, you need to find the steady state voltage of V0. So there are a lot of questions. You need to find the steady state voltage of V0 in all those questions. And this was the question that was asked in GATE examination. So let's start. Now, initially there is no charge on the capacitor at t equals to 0 plus V0 is 0 volt, right? There is no charge on capacitor. So at t equals to 0 plus, what is the VDS value? That is 5 volt. What is the VGS value? That is also 5 volt. What is your VT value? That is 1 volt. Certainly the transistor is on. Transistor is on. Transistor is on. Now you don't need to think whether the transistor will be working in saturation region or linear region. Why? Because you just need to tell the steady state voltage. You don't need to draw any waveform that it will rise linearly or exponentially, how it will rise. No. You just need to tell the steady state voltage. And for steady state voltage, what is necessary? If your transistor is on, then what will happen? This 5 volt from drain. If transistor is on, then there will be current flowing in this direction, right? There will be some current flowing in this direction. So this 5 volt from drain would charge the capacitor. 5 volt from drain will charge the capacitor. Now till what voltage it will charge? Till what voltage it will charge? The capacitor is getting charged with the current, right? The capacitor is getting charged with this ID current. When this ID will be 0? When ID equals to 0 ampere, what will happen? There will be no charging on capacitor, on cap. If ID is 0, there will be no charging. That means you have reached the steady state. You have reached a steady state. If ID is not equals to 0, that means there will be charging. So when do you get 0 ampere current? So if ID is equals to 0, that means capacitor will be charging. When ID is greater than 0, when VGS is greater than VT, or this is the first condition, and the second condition is when VDS is greater than 0 volt. Two conditions are there. So what is the gate potential here? What is the gate potential? That is 5 volt. So from here, what do you see? 5 minus V0 should be greater than or equals to VT. Your V0 should be less than or equals to 4 volt. This is the first condition you get. What about the other one? Your VDS should be greater than 0. That means 5 minus V0 should be greater than 0. So V0 should be less than equals to 5. So two conditions are there, that V0 should be less than 4 and V0 should be less than 5. So what will be the final output? That your V0 should be less than 4 volt. So this is your final output, that your V0 should be less than 4 volt. So what will be the steady state voltage of V0? V0 steady state would be what? 4 volt. V0 steady state will be 4 volt. So this is the simplest method to find the steady state voltage. Now I will give you the intuition. Look, initially I know that transistor will be turning on. So if transistor is turning on, then what will happen? This 5 volt will charge this capacitor in this direction. Now this capacitor will start rising. First from 0 to it will go to 1 volt. Then it will go to 2 volt. Then it will go to 3 volt. It goes to 4 volt. If it is going to 4.01 volt, what will happen? If it is going to 4.01 volt, if capacitor voltage is 4.01 volt, what will be your VGS? VGS would be 5 minus 4.01, 0.99 volt. That is lesser than VT. VT voltage is 1. So if it is lesser than that, then what will happen? Your transistor will be turning off. And if your transistor is off, that means there will be no further charging. If your transistor is off, there is no further charging. There is no charge on the capacitor, no further charge on the capacitor. Let's just say if there was some current flowing in the capacitor, So the capacitor was getting charged. It was continuously getting charged. Let's just assume it is charged to 4 volt. Now the current is gone. Now the current is gone. Now the current source is gone. So what will happen? The capacitor will retain its 4 voltage. This 4 voltage will not go anywhere because there is no discharging path. So capacitor will stay at 4 volt only. There is no discharging path. So capacitor will stay at 4 volt only. And this is what is happening. So always you need to see, okay, this will rise up to 4 volt only. After that, there will be cutoff region. That's it. This is what you need to check when you are solving the questions of these kind of questions if you are solving. Well and good. But we will deal a lot of good questions. So this is the concept. All the time you are not going to write all those things. In the examination, you are not going to write all those things. Once you see the problem only, you will be able to write down the final answer. Let's check out this question. So this 5 volt is going to charge this capacitor, right? This 5 volt will charge this capacitor. So the capacitor will start rising. Okay, the capacitor voltage will start rising. 0, okay, fine. 1 volt, fine. 2 volt, fine. 3 volt, fine. If you get 3.01 volt, what will happen? This VGS value will be less than VT. VGS value at 3.01, what is the VGS value? 0.99, which will be less than VT. So you cannot go here. So you have to stay at 3 volt only. So always you need to make sure that this difference is greater than VT. This difference is greater than VT. That will be your steady state voltage. Steady state voltage will be 3 volt. What about this? What about this? Here, this 4 volt is charging this one. So you go 1 volt, fine. 2 volt, fine. 3 volt, fine. 4 volt you go. It is also fine. Can you go to 4.01 in this one? You cannot even go there. Why so? Because 4 volt is charging. You cannot get more than 4 volt. Your charging voltage is 4 volt only. Can you get more than 4 volt there? No. You cannot get more than 4 volt. Let's just say you say that, sir, because of the drain current, I can get 4.1 volt here. If you get 4.1 volt here, what will happen? This will become drain, right? This will become drain because this is at higher potential and this will become source. Then where will be the current direction? The current will flow like this. And if the current is flowing outward, that means it will be discharging the capacitor. And then it discharges and it discharges till 4 volt only. So when there is 4 volt and 4 volt, there will be steady state. Are you getting this point? Let's just say some guy is having doubt that, sir, why it cannot go to 4.1 volt? If it goes to 4.1 volt, what will happen? There will be current flowing in the opposite direction. The current will be flowing out of the capacitor. If it is flowing out of the capacitor, it will discharge the capacitor. So from 4.1 volt, it will start going down. And if it is going down, then after 4.1 volt, what will happen? It will be 3.9 and here it is 4. Then again it would become drain. Again it would become source. So again it will start charging the capacitor. Again it will start charging the capacitor. So till 4.1 volt only it is till 4 volt only it is going to charge. So the source is of 4 volt only. So maximum voltage you can get is 4 volt. That's it. Maximum voltage you can get is 4 volt only. Right? So here the steady state voltage will be 4 volt. Steady state voltage will be 4 volt. Well and good. Let's see this question. Yeah. So what you will think? That, sir, it can charge up to 5 volt because VT value is 1 volt. So sir, it can charge up to 5 volt. Wrong. Why so? Because the supply is 4 volt only. The given supply is 4 volt only. So maximum it can go up to 4 volt only. That's it. You may think like that, sir, it can go up to 5 volt because my target is to get VGS greater than VT. VGS greater than VT. 6 minus V0 should be greater than VT. So your V0 should be less than 5 volt. But you forgot the other condition. This is only the one condition. This is only one condition. What is the other condition? That your VDS should be greater than or equals to 0. What is your VD? 4. Minus what is your VS? V0. So your V0 should be less than equals to 4 volt. So there are two conditions you are getting. V0 should be less than 5 volt and V0 should be less than 4 volt. So what will be the final answer? V0 maximum value we can get is V0 equals to 4 volt. Right? Because this is saying that V0 should be less than 4 volt and this is saying it should be less than 5 volt. So what is the final answer? Like let's just assume this is 4 volt line and this is 5 volt line. This guy is saying that it should be less than 5 volt and this guy is saying that it should be less than 4 volt. So what is the common area? This is the common area. So this will be acceptable. So what is the maximum value? That is 4 volt. Right? Now see this question. Now at every output you can assume some capacitor. Even if the capacitor is not shown, you can assume the capacitor there. Even if the capacitor is not shown, you can assume the capacitor there. So tell me till what point it will charge. If you see from here, it should charge up to 4 volt. And then you will see at the drain, okay, it can supply 4 volt and it is well and good. It can supply 4 volt, it is well and good. So in the examination, what you will do, you will first see the gate. Okay, gate is at 5. So my source can go up to gate minus VT. Let's just say VT is 1 volt. So my source can go up to 4 volt only. Now, if it is going up to 4 volt, you will see the drain potential. Can drain apply that much of voltage? Yeah, drain can apply that much of voltage. So drain can apply that much of voltage. So drain will be charged to, so source will be charged to 4 volt. Now again from here to here, what will be the final voltage? 2 volt. So you can say 2 volt. But after that you will see at the drain as well. Can drain apply me 2 volt? Yeah, drain can supply you 2 volt. So your steady state voltage at the drain would, at the source would be 2 volt only. Did you understand this question? You started from here. This is 5. You can go up to 4 volt and drain can also apply 4 volt. Well and good. Now this is 4 volt, this is 3 volt. So now this should go up to 2 volt only. Because of 3 volt, it should go up to 2 volt only. Now you will see, can my drain supply me 2 volt? Yeah, drain can supply you 2 volt. That's it. Drain can supply you 2 volt. Drain can supply you up to 4 volt. But it will not go up to 4 volt because after 2 volt only the transistor will be turning off. After 2 volt only the transistor will be turning off. So it will not go up to 4 volt. Drain will say go till 4 volt. But the source will say, but the gate will say no. Only till 2 volt. That's it. Well and good. What about this question? What will be the steady state potential of V01? What drain will say? Drain will say that go up to 5 volt. But what this gate will say? Gate will say go up to 4 volt only. Because your VT is 1. Are you getting this point? What drain would say? Drain would say go up to 5 volt. But what gate will say? Gate will say go up to 4 volt only because after that I will be turning off. So V01 would be over here. Now what this will say? This will say go up to 2 volt only. Now you will ask the gate, will you allow me 2 volt? Yeah, gate is saying I am allowing you 2 volt. So it will be charged till 2 volt only. So gate will allow you till 3 volt. Gate will allow you till 3 volt. Gate says that you can go up to 3 volt. But the drain is saying I have only 2 volt only. So you can go up to 2 volt only. That's it. Did you understand this point? Now let's solve this question. So what this drain would say? Drain would say go up to 5 volt. Go up to 5 volt. But you will ask the gate, will you allow me 5 volt? No. Gate is saying I don't allow you 5 volt. So if gate is not allowing me 5 volt, so I have to till 4 volt only because gate is saying you can go up to 4 volt only. Now what drain is saying? Drain is saying go up to 4 volt. Drain is saying go up to 4 volt. But now you will see, is my gate is allowing me 4 volt? Yeah, gate is allowing you 4 volt because gate says that till 4 volt you can charge. After that I will be turning off. So this is allowing you. Now if this is 4 volt, then what this drain would say? That go up to 4 volt. Go up to 4 volt. Now you will ask your gate, if you are allowing me till 4 volt? Yeah. Gate is saying, yeah, I can allow you till 4 volt because your VT value is 1. After that I will be turning off. After that MOSFET will be turning off. So till 4 volt it is applicable. So 5, then it can go up to 4, then 4, 5, it can go up to 4 only, and again 4, 5, it can go up to 4 volt only. So this is the method of solving the pass transistor logic. What about this? This is 5 and this is 5. Now here there is no arrow mentioned. There is no arrow mentioned. But I told you one thing when I was teaching you the MOS physics part. So what did I tell you? If there is no arrow given, this will be NMOS. And if there is a bubble here, this will be PMOS. So you need to take care of that. Now you have to find the potential of this VA, VB and VC. So everywhere you can assume some capacitor. Now you will say, sir, which one will be drain, which one will be source? So I told you one thing, in case of NMOS, the one which is at higher potential, that will be drain. So this will be drain. And the one which is at lower potential, this is at 0 only because there is no charge on the capacitor. So this will be source. One which is at higher potential, that will be drain, and one which is at lower potential, that will be source in case of NMOS. And in case of PMOS, one which is at higher potential, that will be source, and one which is at lower potential, that will be drain. This I have taught, right? I hope you remember it. So this is the 5 volt battery. Now what this will say, that charge up to 5 volt. But what our gate will say, you cannot charge up to 5 volt. Our gate will say you can charge up to 4 volt only. So it will charge up to 4 volt only. Now this 4 volt will be carried here. What this drain would say? Drain would say that charge up to 4 volt. But what gate will say? Gate is saying that you can charge up to 3 volt only because your VT is 1. So you can charge up to 3 volt only. Now this 3 volt will be carried here. Drain will say charge up to 3 volt. Drain will say charge up to 3 volt. But what this gate would say? Gate would say you cannot charge up to 3 volt. You can charge up to 2 volt only because after that I will be turning off. Now this is 2. This is also 2. Now what this will say? This will say charge up to 2 volt. But what our gate will say? Gate will say that you can charge up to 1 volt only. So these are the final value VA, VB, VC and VD. 4 volt, 3 volt, 2 volt and 1 volt. Well and good. Now this question. So again, tell me the value of VA. That would be 4 volt only because it can charge up to 4 volt only. So this 4 volt will go here. What will be VB value? It is saying go up to 4 volt, but it will allow till 3 volt only. Now this 3 volt will be going here. Now this drain is saying go up to 3 volt, but it will allow up to 2 volt only. Now this is the scene. What is the scene here? This is your 5 volt. This is your 2 volt, and this is your VD, right? What is this? This is PMOS. In case of PMOS, higher potential is source. Higher potential is source and lower potential is drain, right? In case of PMOS, this is the same. So this is the source, this is the drain. Current will be flowing from source to drain. Current will be flowing from source to drain. So basically this is your source and this is your drain. Sorry, gate. There is no doubt about that, this will always be gate. So here in this case, what is your VSG? VSG is 2 minus 5. That is equals to minus 3, and this is your drain, right? That is equals to minus 3 volt. 2 minus 5, that is equals to minus 3 volt. That means your MOS is O. MOS is O. Look, I picked this circuit. There I saw that VC is at 2 volt, gate is at 5 volt, and VD drain is at 0 potential because there is no charge. This is at 0 potential. You can assume a capacitor. There is no charge. There is no initial charge on the capacitor. So VD is at 0 volt. VD is at 0 volt. So this is acting as source and this is acting as gate. So what is your VSG potential? VSG potential is minus 3 volt. Your MOSFET is off. So nothing will happen. Your VD will be 0 volt only. So no charging. No charging for VD. No charging for VD. Because the transistor is not even turning on. Transistor is not even turning on. At least your VC should be 6 volt. Then only your transistor will turn on. Well and good. So let's check a PMOS question in the next one. So what will be the steady state voltage of VA here? What will be the steady state voltage of VA? So this is source. You can certainly tell because this is at higher potential. VA is initially at 0 volt only. So this will be your drain and this is certainly your gate. What is the VSG potential here? VSG. VSG, source to gate, 5 minus 3, that is equals to 2 volt. And it is greater than VT, always. Always. Because here, source and gate potential are fixed. So, it is always greater than VT. Now, this 5 volt will be charging this capacitor, right? This 5 volt will be charging this capacitor. The current will be flowing from source to drain. So, tell me what will be the steady state voltage of VA? VA, steady state voltage of VA will be 5 volt, not 2 volt or anything, not 4 volt or anything. It will be till 5 volt because it will be completely charged. Why so? Why it will be completely charged? Because here you can see that your VSG is 2 volt. That means your transistor will always be on. There is no chance that your transistor will be off. When your transistor will be off? When your VSD value is 0. So your transistor can be off only when your VSD value is 0. Transistor can turn off only when only when VSD is equals to 0. So Vs is at 5 volt, is at 0. So V naught steady state would be 5 volt only. That's it. Are you getting this point? So this is the advantage in case of PMOS. In case of PMOS, if you are applying something at source, if the transistor is on, the complete voltage will be going towards the output. What is the advantage of PMOS? If you are applying something at source and if transistor is on, you set the bias point such that your transistor is on, then complete 5 volt will be going towards the output in the drain side. But in case of NMOS, what was happening? Even if the transistor was on, it was going towards 4 volt only. It was getting till 4 volt only. The source was getting till 4 volt only. Why so? Source was getting till 4 volt only because transistor was turning off there. VGS potential was not fixed. If you put VGS to be lesser than VT, then your transistor will be turned off. But here your VSG potential is fixed. VSG potential is fixed. That is always fixed. So transistor can turn off only when your VSD is equal to 0. So V naught steady state would be 5 volt. So complete 5 volt will be going towards the output. Well and good. So always we should connect the PMOS at higher potential. We should connect the PMOS at higher potential. Why is it so? PMOS can pass good one. Good one means high potential. So this thing we will learn in digital electronics. No need to worry about that. PMOS can pass good one because if source potential is high, that means if source potential is high, so VSG would be high. If VSG is high, that means it will be always on. If it is always on, then complete voltage will be passed. So, but if source potential is low, if source potential is low, then VSG would be less. And if VSG is less, what does that mean? The transistor will not even turn on. So your VA would be 0 volt only. So there will be no charge coming on the output. At the output, you need good amount of charge from the input. So you want your output to charge. So for that, you need to put your source to be high. So PMOS can pass good one. PMOS can pass good one. Good one. One means high voltage. So we will study that in digital electronics. I just give you a reference here. So when you study digital from me, we will deal these kind of things. Right? Okay. Let's see the next circuit. That's it. There are no other circuit. Okay, I can take up more examples. I can take up some more examples. One more question I will deal. Yeah, so this is the question. You need to find the steady state value of this current I. Steady state value of this current I. So if you know the potential here, you can know the current here, right? You just need to find the potential of this one. So if this is 5, till what voltage it will charge? 4 volt only. Because this is your gate. Gate will say that I will allow you till 4 volt only. And this 4 volt is going here. So what drain will say? Drain will say I can allow you till 4 volt. But what gate will say? Gate will say I will allow you till 3 volt only. Now this 3 volt will go here. What this gate will say? Gate will say I will allow you till 2 volt only. Drain will say I can allow you 3 volt, but gate is saying I allow you till 2 volt only. So steady state voltage here would be 2 volt. So what will be the value of I? I would be 2 by 10, 0.2 ampere. That's it. This is your I, right? And this is the question that was asked in the gate examination. So you can tell the final answer. It was asked in 2022. So tell me what this will say. VT value is 1 volt only, 1 and minus 1. So what this will say? This will say that the drain will say that I can allow you till 5 volt, but what source will say I can allow you till 4 volt only. Very basic example. So V1 would be 4 volt. What about V2? V2. So here what is your VSG? VSG 5 minus of minus 5. So VSG is 10 volt. VSG is 10 volt. So your transistor is on. Transistor is on. And if the transistor is on, it will completely charge it. So it will charge it till 5 volt. Steady state voltage, here it is 4 volt and here it will be 5. That's it. Well and good. So in which direction it is charging? This is your source and this is your drain. So important point was it will be 5 or minus 5. Some people were saying when I saw the solution, some people were saying it will be minus 5. Why it will be minus 5? There will be current flowing from source to drain. Current will be flowing from source to drain. So V2 will have plus 5 only. So V2 will have plus 5. So C is the correct answer. Well and good. Everything is crystal clear. So this was the concept of pass transistor logic, which is important for interview perspective as well. Okay. Thank you.